Because it's easy.
What does it say? If two lines are perpendicular, then they intersect to form four right angles. Do you know that?
Yes.
Yes.
Yes, okay. But here's the deal. When you are doing proofs, you have to state that you know that. That's why they give us a perpendicular lines and right angles theorem. Like I said, abbreviate these things. You can even just say definition of perpendicular lines if you want to for me when you're proving something. You don't have to say perpendicular lines and right angles theorem. Okay? Show me you know what you're talking about.
4.3.
This is 4.3.
Boy, give me my pencil.
Okay? And then you have lines perpendicular to a transversal theorem. Okay? Lines perpendicular to a transversal. What's a transversal again?
Line that intersects two parallel.
A line that intersects two parallel lines. Okay? So lines perpendicular to a transversal theorem says if two lines in a plane are perpendicular to the same line, then they are parallel to one another. So here's another way to prove that lines are parallel. If two lines are perpendicular to the same line, then they are parallel to each other. So if M is perpendicular to P and N is perpendicular to P, then M and N are parallel. So M and N are parallel.
Are
The
these
last
are
one.
these in our book?
Yes, they're all in your book. The last one is the perpendicular transversal theorem. Perpendicular transversal theorem. If a transversal is perpendicular to one of a pair of parallel lines, then it is perpendicular to the other parallel line. So if I have a transversal and it's marked as being perpendicular to one of the two parallel lines, then I also know it's perpendicular to the other parallel line. I feel like these three are pretty common sense. Because perpendicular lines we can see when they're 90-degree angles. It makes more sense to us in our heads. Okay? So if M is perpendicular to X and X is parallel to Y, then M is perpendicular to Y, and vice versa. If M is perpendicular to Y and X is parallel to Y, then M is perpendicular to X. So you have three theorems about perpendicular. Perpendicular and right angles. If a line is perpendicular to another line, it causes four right angles. Lines perpendicular to a transversal. If a line is perpendicular, if two lines are perpendicular to the same line, then those two lines are parallel. And then perpendicular transversal theorem says if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other line as well.
No.
Okay. Questions on any of those three theorems? Okay, here we go. Okay, so they want us to prove, well, they give us this diagram, line M and N and line O and P. And they say prove that O is perpendicular to M. Prove that O is perpendicular to M. O is perpendicular to M. What is our givens? What do we know?
There's four.
Okay, you know that O and why do you know O and P are parallel? Does it show that they're parallel?
Yes.
Yep.
Well,
Wait, does that top left one have a square in it?
What?
the top left one have the 90 degrees for,
There's a 90 degree here, here, and here.
but not the top left one?
What do you know? Okay, so we don't know, there's no arrows, so we don't know that they're parallel, but can we prove that they're parallel? How?
The corresponding angles question.
Okay, so I can say, that O is parallel to P because of corresponding angles converse,
Yeah.
corresponding angles converse. Okay? I can prove that those are parallel because they are corresponding angles converse. Perfect. So now I know O and P are parallel. You know from your given that M is perpendicular to P, right? Okay? Well, if I know that O is parallel to P because of corresponding angles converse, and I know M is perpendicular to P, what then do I know?
M and O intersect because of the,
I know that M is perpendicular to O because of one of those three that you just wrote down. Which one?
What would you write for the reason?
Whatever one of those three are that you just wrote down. What's the reason?
the perpendicular transversal theorem
Perpendicular transversal theorem.
on the node.
Does that say, what does it say, prove O is what's in?
On the node.
Which one?
The top left.
O
very-
is parallel to P.
No, like the top very left, the small words, it says prove something.
Says prove O is perpendicular to M, or, yeah, which is what we're doing. So, perpendicular transversal theorem, right?
Yes. You wanna talk
Yeah,
to
Yo,
me?
hey,
Okay. So, that's how you can prove that those are perpendicular. Okay, the last thing we're gonna talk about, I'm just gonna walk you through this, we're gonna talk about two things and then, you're gonna just do homework, because this isn't something that is a rule, it's something that you instruct. Compass, yes? Okay, so they're saying, let's say you have, a line, and they want you to construct a line that is parallel to that line. You have to actually use a compass, they're not gonna let you just eyeball it and use a ruler, you have to use a compass and show yourself. So what you do is, on your original line, you pick 2 points, okay? Here they have a point right there, and they have a point right here, this is so awful, okay? So they have 2 points. When you go to figure out how to make this line that is parallel, you have to use your compass. You're going to take your compass, the width, okay, is going to be set to a little less than the width of those 2 dots. Okay, more than half, but less than the full amount. When I do that, I then use that measurement to create a, from the center point, from the center of that, to create a arc. And then I flip it and do it the other way. Where those arcs connect, do you see how these have connectors, the arcs? You take a ruler and you line it up and you draw your perpendicular bisector.
Yeah.
Okay? When you draw that perpendicular bisector, you can now use that to draw your parallel lines. Because when I have a perpendicular bisector, I now have lines that are parallel to each other off of the theorem that we just talked about. Okay? So then you can take your ruler, your straight edge, and between the 2 points of that line that you caused to be your perpendicular bisector, you can draw a line to create your parallel lines. It's very simple. And then the last one is this. So they're saying, here you have a grid, but let's pretend that we don't have a grid, because I know that if we have a grid, you're smart enough to count. Yes, and tell me the distance of something. Okay? So if you don't have a grid, they want to know what is the distance between the point and the line. Okay? So what's the difference? What's the distance between this line and this point? If you create a perpendicular bisector from there, you can figure out what the distance is by using the what formula?
Counting.
If I'm figuring out the distance, what formula am I using? Oh, look at that, the distance formula. Okay, so what you would do is you would take your compass again and make your arc so that you can draw this line that comes, okay, that comes straight through there.
You need to recalibrate.
I know I do.
Wait,
Somebody probably hit it and then it messed it up. So you would draw that, and then you would have from here to here, you would use your distance formula to figure out what that
Couldn't
distance
just
was.
like four,
Yeah.
That's what I just said. If it wasn't on a grid, you would have to do it that way. If it's on a grid, I can just take the points, right, and I can plug them into the distance formula. I can plug in 2, -1, and I can plug in 2, 3, and figure out what the distance is, correct?
Can we do an example?
Can you what?
Do an example.
That is an example.
how do you do it
You
on?
take the distance formula of 2, -1, because I'm looking at the points, and 2, 3, and plug it in.
Okay.
What is the formula for distance formula?
It's like
See?
square root of
X1
X.
minus X2 to the second. Plus Y1 minus Y2.
Yes, Brady, it is.
Why?
Okay, so, 2 minus 2 squared plus.
Wait,
what
Brady
is it?
got something right again? I'm not directing.
-1 minus 3 squared, right? Take the square root of that, this is 0, this is -4, -4 squared is 16, right? So take the square root of that and you get 4. So when you are finding that, you're using the distance formula, okay? Or the absolute value of the difference, which is the same thing as the distance formula. Those are the things you're working on tonight. It's pretty much a repeat of what we did yesterday and the day before, with just those 3 other rules added in. Okay? Does that make sense? Okay, it's more practice on the same stuff.